Hello everyone. On this video we will be going over the difference quotient. Alright, so to kind of give you an idea of what that is, I want you to think back to how to find the slope of a function, or the slope of a graph. Alright, so we draw our XY axis. And let's say this is point, we'll call this value x number 1, and we'll call this value x number 2. Okay, so we'll call this value y number 1. We'll call this value y number 2. Okay, so let's say if you have a linear function that goes through where those points intersect. Okay, remember, if you wanted to find the slope, that's y2 minus y1 over x2 minus x1, or rise over run. Okay, remember your slope is actually just denoted by the letter m in most cases. So you have y2 minus y1 over x2 minus x1. Okay, so it's the same general idea to come up with the difference quotient. Okay, so let's say, slide this up. So you have the same xy axis. Make it a little bit bigger. There we go. For our x, and we have our y. Okay, now instead of x1 and x number 2, x value number 1 and x value number 2, let's say we make this x, and to ensure that we're going to the right, our next value will be x plus some value h. So if you have 3 here and 5 here, your x would be 3, and your x plus h would be 3 plus 2, which is your 5. That's just an example, so you'll have an idea of what that means. Okay, so instead of your y, we're going to be f of x. So let's say we have that same slope. This is your x, f of x. So let me lower that a little bit so it's actually even with the point on the slope. There we go. And this is your x plus h, which makes this your f of x plus h. Okay, so instead of y2 minus y1, your slope will equal f of x plus h minus f of x. X plus h minus f of x. Over, and instead of x2 minus x1, you're going to be x plus h minus x. Okay, now notice the difference between your two x values is h. And again, just think of the example if you have 3 here and a 5 here. You have 3 and 3 plus 2. Okay, so it's the same thing. That distance between those two x values is h. So your x plus h minus x, those two x's cancel out. So it ends up equaling f of x plus h minus f of x all over h. And this is what you call your difference quotient. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our first example. All right. So let's say, for example, we want to find the difference quotient for f of x equals negative 5x plus 7. Alright, so using our difference quotient formula, you have f of x plus h minus f of x all over h. Alright, so the first thing you do is we're going to find our f of x plus h. Okay, so our f of x plus h, since this is our f of x, we just replace every x with x plus h. So that's going to equal negative 5x plus h plus 7. Okay, so if we go ahead and distribute that negative 5, that means our f of x plus h is negative 5x minus 5h plus 7. Okay, so this is our f of x plus h. Alright, so now for our second step, well, we already know our f of x. So for our second step, we're going to go ahead and plug it in. Okay, so f of x is equal to, we have that up there, negative 5x plus 7. We go ahead and plug that in. So f of x plus h minus f of x all over h. It's just going to equal, if we replace f of x plus h, remember that's negative 5x minus 5h plus 7. So negative 5x minus 5h plus 7 minus f of x, which is just negative 5x plus 7 all over h. Okay, now you want to, at least a good habit is to put the parentheses around each one of those separately, because remember with this minus, you have to distribute that to both. And sometimes if you forget to put the parentheses, you can have that as minus negative and then leave that as positive by mistake. So you don't want to do that. So putting parentheses around each one of those is a good habit. Not necessary, but a good habit. Alright, so if we go ahead and distribute that negative, we have negative 5x minus 5h plus 7 plus 5x minus 7 all over h. And if you did it correctly, things should start canceling out. You have your minus 5x and plus 5x, those cancel out. You have your plus 7 and minus 7, those two cancel out. So you're left with negative 5h over h, where those two cancel out, and you end up with a negative 5. Alright, so if you are still writing, feel free to press pause, but we'll go ahead and do another example. Alright, so let's say, for example, we want to find the difference quotient difference quotient for f of x equals x squared. Alright, so our difference quotient formula. We know that's f of x plus h minus f of x all over h. Okay. So just like before, first thing you do, you find your f of x plus h. Okay. So since our f of x is equal to x squared, f of x plus h is just replacing every x with x plus h. So that's x plus h squared. Alright, so we go ahead and x plus h squared is just x plus h times x plus h. Alright, so if we go ahead and FOIL method on that one, that gives us x squared plus xh plus xh plus h squared. Our first, outer, inner, last. Okay, so if we go ahead and combine those two terms, x plus h, or x times h plus x times h is 2xh. So our f of x plus h is going to equal x squared plus 2xh plus h squared. Alright, let me see if I can focus that a little bit. Yeah, that's a little bit better. Okay. Now your second step, we're just going to go ahead and plug it into the formula, and we already know our f of x is equal to x squared. Okay, so that means our f of x plus h minus f of x all over h is just going to be our f of x plus h. We replace it with this. So you have x squared plus 2xh plus h squared all over, forgot my minus. Minus f of x, which is minus x squared all over h. Alright, so this is positive, so we can go ahead and drop these parentheses. So you have x squared plus 2xh plus h squared minus x squared all over h. Okay, so since these two cancel each other out, you have x squared minus x squared, those cancel out. That leaves you with 2xh plus h squared all over h. Alright, so again, if you have a nonlinear function, okay, here it's x squared, so it's not linear. Every term in your numerator should have an h that you can factor out if you did it correctly. If you don't have an h in each term to factor out, then you may have messed up somewhere. But here you can factor an h out of both of those terms. So that's going to equal h times 2x plus h. Of course, if you distribute it, you get that back, so you can always double check it, all over h. Okay, so those two will cancel out, so you end up with 2x plus h as your difference quotient. Alright, so if you are still writing, feel free to press pause, but we'll go ahead and do one more example. Break my paper here. There we go. Okay, so let's say, for example, we want to find the difference quotient for f of x is equal to 2x squared plus 3x minus 1. Alright, so what I want you to do is go ahead and press pause and try to find this difference quotient on your own. Alright, so I'm assuming you've pressed pause and worked this one out on your own. So let's go ahead and verify your answer. Okay, again, the difference quotient. Yeah, might as well put the equal sign. F of x plus h minus f of x all over h. Okay, so once again, first thing you want to do is find f of x plus h, because we already know our f of x. Okay, so we know the f of x plus h. Again, replace every x plus x with x plus h. So that's 2 times x plus h squared plus 3 times x plus h minus 1. Okay, so this one, we can FOIL that. So just making a little side note. If you have x plus h squared, that's just x plus h times x plus h. Where once you FOIL that out, it's x squared plus 2xh plus h squared. Okay, so this just becomes 2 times x squared plus 2xh plus h squared plus 3 times x plus h minus 1. So if we go ahead and distribute that 2 to all of those terms, you have 2x squared plus 4xh plus 2h squared. And if we go ahead and distribute that 3 plus 3x plus 3h minus 1. And that will give you your f of x plus h. Alright, so it can get a little bit lengthy, but try to take your time and don't make any errors. You should be okay. Or at least try to not make any errors. Sometimes they happen. Okay, so now we go to our second step and just plug it in. Okay, so we know that f of x is equal to 2x squared plus 3x minus 1. So if we go ahead and plug those in, your f of x plus h minus f of x all over h will equal your f of x plus h is all of this. So you have 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 1 minus your f of x, which is 2x squared plus 3x minus 1, all of that over h. Okay, so our f of x plus h minus f of x all over h. Okay, so once again, we go ahead and distribute that negative. And this is all positive here, so we can just drop the parentheses. So you have 2x squared plus, move that up some, 4xh plus 2h squared plus 3x plus 3h minus 1. We distribute that negative, minus 2x squared minus 3x plus 1. And all of that over h. Alright, so once again, if you did it correctly, things should start canceling out. You have 2x squared minus 2x squared. You have plus 3x minus 3x. You have minus 1 plus 1. Okay, now remember the hint. Every term left after canceling out should have an h next to it. If you're left with a term that doesn't have an h next to it after canceling out, you may want to go back and double check just to make sure you didn't miss anything. Okay, so you have 4xh plus 2h squared plus 3h all over h. Alright, so we go ahead and factor an h out of each of those terms. Move that up. That will give us h times 4x plus 2h plus 3 all over h, where those two can cancel out. And that leaves us with 4x plus 2h plus 3 as our difference quotient. Alright, so hopefully this made sense, and I will see you on the next video.